In this lesson, we are doing section 12.2, just part 1, and we are working with combinations to count the number of ways that an event can happen. A combination is an unordered grouping of objects where order doesn't matter. We use the symbol capital C for combination, where N stands for the number of objects that we are talking about, and R stands for how many combinations we have. And we calculate it by doing N factorial, or the number of objects, in the numerator, and then in the denominator we have N minus R by subtracting the objects and how many combinations we want factorial, and multiply that by the combinations factorial. So let's take a look at an example. Using a standard 52 card deck, if order is not important, how many different 7 card hands are possible? So when we're talking about 7 card hands, we would do a combination. And so for this particular item, we have 52 cards. And we want to select 7 of those cards, and the order doesn't matter. So when we are doing that, we do however many choices we have. So that's 52 factorial divided by, and we have subtract the 2, we have 52 minus 7 factorial times 7 factorial. So when we're calculating, we have 52 factorial divided by, and 52 minus 7 would be 45 factorial, and 7, multiply that by 7 factorial, and make sure that when you are using this, you're putting this in parentheses in the denominator when we're multiplying. Again, your best bet is to go into your calculator, to go into the math menu, and what we would do would be to enter 52 first, then go into the math menu, arrow over to probability, and you'll see the combination item to select, then press the number 7, and then press equals. And this is quite a large number. It comes out to be 133,784,560 different ways that you could make that 7 card hand possible. The next question says, how many of these hands have all 7 cards of the same suit? All 7 cards being the same suit. So here's how we work this one out. Our first combination is that there are 13 cards in a suit, and we're going to pick 7 of those cards. And also we need to talk about the suits. We will multiply that by, there are 4 suits in a deck, and we are going to select one of the suits. So again, the first combination I'm worried about is that there are 13 cards in a suit, and I'm going to pick 7 cards, and we multiply that by, we know that there are 4 suits in a deck, and we are going to pick one of those suits. So we have 13 factorial divided by 13 minus 7, which is 6 factorial, times 7 factorial. And then we're multiplying that by 4 factorial divided by, we have 4 minus 1 factorial, which is 3 factorial, times 1 factorial. Or, and you can work it out that way with your calculator, or you can simply punch in 13 factorial, or combination where you have 13 items, you're selecting 7 of them, times the combination where you have 4 items and you're selecting 1 of them. So that's going to give you 1,716 times 4, which is 6,864 different hands that you would get. Let's take a look at the next example. Find the number of possible 5 card hands with the given information. 2 aces and 3 kings. So when I have 2 aces and 3 kings, I'm going to have 2 aces. Well, there are 4 aces in the deck. So my combination would be that I have 4 aces and I'm selecting 2 of them. And We're going to multiply that together. I have a combination where I want to pick 3 kings. There are 4 kings in a deck, and I am going to pick 3 of them. So using your calculator, we can multiply that out, and that's going to give us an answer of 24 different possible hands where you pick 2 aces and 3 kings. Notice the word and. Just like the previous slide, when I have 7 cards of the same suit. So I have to make sure that they are of the same suit. So I have 1 suit and all 7 cards are from that suit. Here's the next example. I have 1 ace and I have 4 other cards. So the combination would be I have 4 aces in a deck and I'm going to pick one of those aces. And I have 4 other cards. So the rest of the cards in the deck, I would take 52 and I would subtract my 4 aces. So I have 48 other cards in the deck and I'm going to pick 4 of those. So we can use our calculator to use combinations by again going into the math menu. Make sure you put the choices in, the possibles in first and then how many you're selecting, and then multiply that out. Or we can write it out as, remember the first combination is 4 factorial. 4 minus 1 would be 3 factorial, 1 factorial, times, we have 48 factorial, and then we have 48 minus 4 would be 44 factorial, times 4 factorial. And regardless of the way that you work that out, we come out with 778,320 different hands that would be created from this combination. Here is another type of problem that's going to be different. From a group of 20 volunteers, you are choosing at least 18 to be peer counselors, which means you could have 18 or 19 or 20 because it says at least. So when we have the word or, we are going to be adding the combinations together. So I could have my 20 volunteers and I could pick 18 of them to be peer counselors. Or I can have my group of 20 volunteers and I can pick 19 of them to be counselors. Or I can have my group of 20 and I can pick 20 of them to be counselors. So when we're calculating, we can calculate each of these separately and then we can add them together. So when we calculate, this is 190 plus we have 20 plus 1, which would give us 211 different ways that I can arrange. A restaurant offered 6 salad toppings. On a deluxe salad, you can have up to 4 toppings. So that means I could have 4, or I could have 3 toppings, or I could have 2, or I could have 1, or I could have no toppings and just have the lettuce. So we will do our different combinations with each of these. There are 6 toppings, and I'm going to select 4 of them. Or there are 6 toppings and I'm going to select 3 of them. Or there are 6 toppings and I'm going to select 2 of them. Or 1 of them. Or none at all. So I have 15, 20, 15, 6, and 1 for a total of 57 different combinations that we could have with that salad. Let's review. A combination is a group of unordered objects. Remember, order doesn't matter, and when we're calculating, we use the formula of combination, where n is the number of objects I'm choosing from and r is how many I'm selecting. We take n factorial divided by n minus r factorial times r factorial. Please remember to watch also for the words such as at least or up to, and that gives you a clue that it's an or situation where you're going to be adding. When we have items such as cards where we have one ace and 4 other cards, that means we're going to be multiplying those combinations together.